Yes, the derivative of the inverse function, please. All right, Moshe. Let's see. Right, guys, are we ready? So let's do that. What's usually the first question to ask? Well, the first question should be why. In this case, we can just say y equal to f inverse of x. Yes, so that allows me to, so I'm going to do that using implicit differentiation. So I will apply f on both sides. So on one hand, if I apply f to y, that will give me f of f inverse of x, which is x. On the other hand, anything that f eats, it takes the cubed root of, and yes, this is what we get. Agreed? That's f of y. You might prefer to write this function as 1 plus x cubed to the power of 1/3. So then what's the derivative of this function by implicit differentiation? The derivative of the 1/3 power is 1/3, 1 plus y cubed to the power of minus 2/3 times 3 times y squared times y prime. This is chain rule here. And that's the derivative of x, which is 1. Are you with me, guys? Yes, so that's by implicit differentiation. I can quickly accomplish that. By the way, turn on your cameras, guys. It's rather sad here. So what do we get from that situation? So we then get y prime. You see that from the previous slide. So the 3's are crossed out, so I just have to multiply by 1 plus y cubed to the power of 2/3 on both sides and divide by y squared. So that would be 1 plus y cubed to the power of 2/3 divided by y squared. Now, do you recognize anything here, guys? Look at it. It's y prime equal to 1 plus y cubed to the power of 1/3 squared over y squared. Now, why did I write it this way? Do you see that 1 plus y cubed to the 1/3 power is just x? So that entire expression can be written as x squared divided by y squared. So that means that the derivative of the inverse function is x squared divided by the inverse function squared. Do you agree? So basically the derivative of this function is x squared divided by the inverse raised to the second power. I can simplify that because in this case it's not very difficult to find the inverse function, right? So if I have that f of x is equal to the cube root of 1 plus x cubed, right? So that means that if the inverse is equal to y, that means that x is equal to the cube root of 1 plus y cubed, which means that x cubed minus 1 cube root is y. Which means that my formula for the derivative of the inverse in explicit terms is x squared divided by the cube root of x cubed minus 1 squared. Understood? Let's see if you understood, guys. Here is another example. So the function is f of x equal to e to the power of 5x. E to the power of 5x, I want you to tell me what's the derivative of the inverse function. See if you follow the same steps. Moshe, I haven't seen you in a while, by the way. Maybe never even. Enrique, Sofia, Nicole, Dorian, Sarah, Jeffrey. Here we go. Jeffrey, Nicole, Toju, or whatnot. Yeah. But you know, I am a very visual person. And I don't like abstract art. Fine, fine. Brian P, Safa, Elmira, Romaro. No? Hmm. Hmm. Maybe next time. The derivative of the inverse motion. Who knows? The final is coming soon. And we're moving very slowly. I hope that in a foreign language that means inverse. So Sophia, so the final is on May 25th. Yes? Well, congratulations. All right, guys, let's do it together. It should take you, for a question like this, it should take you a minute. Yeah, I would not be surprised if it's earlier. So here is the situation. #21, huh? No? What can I say? So here is the situation. So what do we do first? We can label y to be f inverse x. Yes? Y is f inverse x. Which means that f of y is f inverse x, which is x. What is f of y? F of y is e to the 5y equals to x. Now what's the derivative? The derivative of e to the 5y is e to the 5y prime equal to 1. Guys, if you have questions, if something is confusing, do you understand why the strategy works? The strategy is specifically that the inverse function and the function are geometrically the same. Do you remember, guys, finding the derivative is to find slope of the tangent line. But that means really to see that the curve is made of a line segment. If you view the curve this way, it's the function f. If you view the curve this way, it's the function f inverse. It's geometrically one and the same curve. The curve root of x and the curve y squared are the same curves. Do you understand? We will talk about it one more time a little bit, which means that if I know that one is differentiable, the other one is automatically differentiable. That's clear geometrically. So we have e to the 5y times 5 is the derivative of e to the 5y times y prime is equal to 1, which means the y prime is equal to 1 over 5e to the 5y. But e to the 5y is equal to x, which means that we get 1 over 5x. Yes? Do you see how I solved it, guys? Did it take me long? No. It should take you less than a minute to solve a problem like this. Train accordingly. If you feel you're behind, you can stay after class. I will give you more problems. We can train. All right, here is one more. Suppose that we have the function f of x equal to the fifth root of 1 plus e to the x. I would like you to tell me what's the derivative of the inverse function. the derivative. John and everyone else, I want to see the derivative. All right, let's do that step by step. What would you say? What would you do first? Y. Why what? Y equals to the inverse function. Very good. Do you understand that this is just a, why do I say y equals to the inverse function? The idea geometrically is that I will see two sides, right? The two sides of the curve is looked from one way, it's the inverse function, looked from the other, it's the familiar curve for which I have the formula. So that means that f of y is equal to x, but on the other hand equals to 1 plus e to the power of x, e to the power of y, I'm sorry, to the power of 1/5. Yes? What's the derivative? It's 1/5, 1 plus e to the y to the power of minus 4/5 times times e to the y times derivative of the inside is e to the y, and then times y prime. So it's times e to the y times y prime. And that's supposed to equal to 1. I multiply by 5 and by 1 plus e to the y to the power of 4/5. So what do I get? I get that, and then divide by e to the y, so I get that y prime is equal to 5 1 plus e to the y to the power of 4/5 divided by e to the y. Agreed? Now, what is...
Professor, what did you do here once again?
I just multiplied to, I'm just simplifying to get y prime, so I multiply by the expression at time here, I need to multiply it by 5, and here I need to multiply by 1 plus e to the y to the power of 4/5 to get rid of it here. I'm just basically taking carrying as simple as that, as to carry this thing across the equal sign, because I am I'm only interested in y prime. Yes. You see, so this is, I'm just solving for y prime, just algebra, just move things across. Here is the y prime. Are you with me, guys? You should, I mean, if you're not with me, guys, this is ax equal to b, right? I mean, how do you solve for x? Just divide by a, right? It's basically this motion to move it across is the same as when you think like 3x equal to 6. What do? You just divide by 3. So it's x equal to 6 over 3. Same idea. What's the difference? It's the left side equal to the right side. I'm interested in y prime. Yes? So then what is 1 plus e to the y to the power of 4 over 5? Can I simplify this expression a little, the numerator? Can you please tell me a simpler formula for the numerator? For the numerator, you see? Five x to the 4, precisely. Why is it 5x to the 4? Look at it, guys. Do you see that 1 plus e to the y to the 1/5 equals 2x? Are you seeing it? Look at it here. Do you see this formula? Do you see that the formula appears here? So that means that I can simplify it and write 5x to the power of 4. Are you with me? For the numerator. Divided by e to the y. How do I get e to the y? Well, I mean, in this case, if I want a simpler formula for e to the y, I have to calculate, look at it, e to the y. I just take, I just have this expression, right? So we have that 1 plus e to the y to the 1/5 is equal to x. So e to the y is equal to x minus 1 to the power of 5. Do you agree? E to the y is x minus 1 to the power of 5, which is exactly what I can place there. So I can simply say this is 5x to the 4, and then here it's sorry, what did I say? It's x to the power of 5, and I think I made a mistake. It's x to the power of 5 minus 1. That should be right, because I need to say solve for e to the y. Now, how do you get e to the y here? You take to the 5th power and subtract 1. I think I wrote something else. Yes? Make sense? This is the derivative. It's as simple as that. Now, guys, I would like to see if you understand the idea, and maybe you right away know the derivative. I'm not interested in what you know. I'm interested in what you think. So suppose, guys, that you needed to find the derivative of ln of x. Would you advise, how do I carry out this derivative? Do you remember what is ln of x? If you don't, it is log base e of x. How do I find the derivative of ln of x from what we know from before? Tell me what is 2 steps, not the answer. I mean, maybe you can Google it or know it. Tell me 2 steps that I need to carry to figure it out on my own. Do you understand my question, guys? It's difficult to type a full proof, but tell me what's the idea? So limit as h approaches 0, then you're thinking take the definition of the derivative. You can try, and there is a way to do that, but we know something about this function, right? What are we looking at? You see, guys, you're not thinking exactly. The inverse of a function. You need to think about space. Do you know the song? Well, of course you don't. Земля в иллюминаторе, the earth inside of... we need to probably play that song for you so you understand something. Yes. What is ln of x, guys? This is y equal to ln of x. Yes, that's the graph of the curve. We're going to actually do that in a moment, right? So yes, exactly, Moshe. Here you go. The ln of x, it's the same curve. Can you imagine you're spinning in space? What is it? Let's see. Interesting. Moshe. Well, we'll see. We'll see in a moment. Y is equal to ln of x is the same as the curve e to the y equal to e to the ln of x, which is equal to x. Do you agree? Yes? And so what's the derivative of this function? The derivative of this function is simply e to the y prime equal to 1, which means that y prime is equal to 1 over e to the y. And what is e to the y, guys? E to the y is x. So it's 1 over x. Let's now see this in slow motion. Why am I, you see, guys, imagination. Let's now visualize the same situation. Let's look at the astronauts. What are they seeing? How are you going to do that? And try to help me. Because I mean, some of you write stuff and I am not sure if you understand or if you copy another person's writing, for instance, you know? I'm noticing an interesting pattern here. It doesn't matter what the actual shape of the curve is, but trust me, it doesn't matter at all. I know the shape, but here is my function. Yes, this is the function y equal to ln x, the function I'm trying to differentiate. Would anybody care to either speak or write in a short comment, what am I trying to find? What am I saying? Differentiate ln of x, differentiate a function. What am I really saying exactly? And visual, I mean, you see, not the definition, not anything visual. What am I saying about this curve? What am I trying to find about this curve? Exactly. Find the slope of what? So in particular, guys, find the slope of a line segment. Yes? Find the slope of a line segment, because I am claiming that perhaps this curve, if you look at it under a microscope, would look anywhere where you look, would look like some line segment, and I just need to specify the slope. But do you agree that the slope, look at it, guys, can you imagine here, the same line, either it rotates or I am rotating with respect to that line, it doesn't matter. There is one line, and there is my perspective on it. So when I report slope, I report my perspective. Do you see that? So there are two astronauts here. I mean, one astronaut will help another. So y equals ln x means that if you look at the astronaut red, so there is astronaut red and green. The astronaut red looks at this point. and this point is X. Here is where his flag is located. Astronaut red looks at this position of the flag, looks up on this curve, and sees that for any point, he sees this regularity. For any place on the X coordinate, the corresponding place on the Y coordinate the vertical, basically for him, for red's vertical, for any horizontal, for any red's horizontal is vertical is given by ln of X. Yes? Now, an astronaut walking on the y-axis, here is the flag for that astronaut. Yes? What is that astronaut seeing? So from the perspective of the red astronaut, from the red perspective, he specifies the coordinates this way. He says, my second coordinate is the logarithm, the natural logarithm of the first. But for the green astronaut, for astronaut green, he sees the situation entirely differently. His horizontal coordinate is here. Do you see the perspective? For him, in space, guys, right? For him, this is the horizontal coordinate. Are you with me? And then what will he say is the vertical coordinate? What is the vertical coordinate? No, that is, again, green's vertical coordinate. Green's vertical coordinate is e to the y. Do you understand that? In other words, the person green, astronaut green, is seeing a familiar curve e to the y. Are you with me? Simple question, guys. Do you follow? Copied? You know that when you are in space, you usually ask the astronauts to confirm their vitals, right? You know that, yes? And if the astronaut does not respond, you imagine oxygen has been gone out of their brain and they are suffering a hypoxia, or maybe they're plainly stupid. That's two possibilities, right? Here is that line segment. So red astronaut wants to measure the slope at the point X, which means he wants to measure rise over run. You understand the perspective, guys? What is horizontal? It's a stupid question, meaningless. There is no such thing as horizontal, there is no such thing as vertical, there is no such thing as left, and there is no such thing as right. And I know that because I drive cars. And we're in near accidents because of it. Because others don't understand there is no left or right, up or down, it's all relative. My left is where my heart is. So similarly, guys, the green guy, what is his horizontal? His horizontal is the y-axis. And his vertical is the x-axis. The astronaut red, for him, it's all reversed. Yes? So, but astronaut green recognizes this curve in a much more familiar form. For him, what is the curve, guys? For him, for astronaut red, the curve is just the exponential, the very familiar exponential function. So astronaut green sees the following. He reports that the slope here, his report of the slope, the green's report of slope at the same point, for him, this is the point y, right? This is the point. The guy wants to report the slope at x. For him, it's the corresponding point is ln x. So for him, the slope is what? For him, the slope is e to the y, which is e to the ln x. You understand? He reports slope here. And his slope that he reports is given by dx dy. Because it's rise over run. But for him, the rise is dx and the run is dy. Clear? Now he easily can figure out that slope for this. Says that, oh, the slope is just the position x. So it says to the red guy, it says, from my perspective, the slope of the line you're looking at, it's the same as the coordinate at which you stand. Which means what? Which means the red guy says, aha, now I know my slope. My slope is dy dx, which is equal to 1 over dx dy, which is equal to 1 over x. Do you understand why 1? They are watching the same line. They are just not agreeing on what's vertical and what's horizontal. So the reason it's 1 over, it's because for the red astronaut, the notion of vertical and horizontal are switched relative to the green guy. You follow? Yes, guys, you communicate about the same line. It's like, guys, am I sitting upright or not, right? I mean, if you turn the camera, I will be upside down. It's a matter of perspective. Do you understand? Same line, different perspectives. Exactly. That's the differential geometry point of view. Same line, different perspectives. Slope is just a very subjective report. You understand? So when you study differentiation later on in mathematics, you are more focused on the actual line. The slope is a matter of perspective. All right, let's see if you understood this process, guys. You're going to derive the inverse function formula. You're going to figure out how to find the derivative of any function. See if you can do that. Give me a formula. So here we have, suppose that we know how to differentiate. How to differentiate the function f of x. It's completely abstract. It could be any function, but we know how to differentiate it. We have a formula. Find the formula for the derivative of f inverse x in terms of f naturally. You understand, guys? So we want to come up with a quick formula to differentiate any inverse function without doing a lot of work. Right away, know what to do. Okay, Brianna, interesting. We'll wait a little bit. Two more minutes, okay? All right, guys, let's do it together then. You can think of it geometrically, you can calculate even faster this way. Y equal to F inverse X. I want to find the derivative. So what do I do? Tell me what's the next step. You understand? F inverse is a form, I mean, it's a perspective on the curve that I am not comfortable with. So what do? I change the perspective. Tell me what should I do functionally to change the perspective? Apply to both sides of the equation. What? To both sides of the equation, I apply. Yes, I apply F. So if I apply F to Y, I will get X. Now, what's the derivative of the left side? The derivative of the left side is F prime Y times Y prime, where Y prime is what I'm seeking. Y prime is the derivative that I want. It's equal to 1. So what is Y prime? It's 1 over the derivative of F at Y. You see why is it 1 over? Because it's change in perspective. Do you understand why 1 over, right? F prime was the perspective of the function F. 1 over f prime is the perspective for the inverse in this form. Now, what is y? Y is f inverse x. So the answer is 1 over f prime f inverse x. How is that supposed to help me? So how does it work? How is this theorem working? Suppose that y is equal to, let's say, x to the power of 1 over n, the nth root. Okay? I don't know how to differentiate the, I mean, maybe you're familiar already, you think you know how to differentiate the in-rule, but we haven't derived the formula here, yes? So what we can do is we can say, okay, y to the n is, is x, which means n, y to the n minus 1 is 1, well, times y prime is 1, so y prime is 1 over n, y to the n minus 1, which is 1 over n, x to the power of n minus 1 over n, which gives us the familiar formula 1 over n, x to the power of 1 minus, or 1 over n minus 1. Yeah? Now help me with the next question, guys. I want you to remind me how to take the derivative of a to the power of x. In particular, how to modify the question. Tell me what step do I do to modify this question and see the derivative right away. And of course, you should think, of course, always think of what do you want to see instead. Would you have preferred a similar problem, but one that does not use an arbitrary a? Exactly. You would prefer e to the x. So let's place it there. So it's e to the ln ax. Do you see why I placed ln? Because I had a to the x, but I want to see e. Now, what is that? This is the derivative. I can move the x. Remember the properties of logarithms, guys? I can take this x and I can move it down. So that's the derivative of e x ln a, and ln a is just a number. So the derivative of x ln a is x e to the x ln a times ln a, which is e to the x ln a is back to the point of a to the x times ln a. That's my derivative. If you understood, I want you to tell me what's the derivative now of logarithm base a of x. Tell me what's the derivative of a logarithm where instead of e I use base a. Another thing, guys, I would like you to tell me how you are, I mean, the answer you can Google. Show me that you know how to do this problem. Show me a step that convinces me that you understand how to derive this. There are two ways of doing this question, guys. Here is one way. I can say y equals to log base ax, which means a to the power of y, which is a to the log base ax, is x. Agreed? The derivative of a to the y is a to the power of y ln a, as we just saw, times y prime. And that's supposed to equal to 1. So that means, and y prime is the derivative of the function I want. So what is y prime? Y prime is 1 over a to the y ln a. Agreed? And what is a to the y? A to the y is just x. So it's 1 over x ln a. Another method 2. I can always convert logarithm base a of x to logarithm base b of x for any a to b. How do I do the conversion? In other words, guys, we know the derivative of ln, right? We know that the derivative of ln is 1 over x, but the derivative of log base ax, what is it? We are not so right away aware. Here is the change of basis formula. How do you obtain it? So how do I convert logarithm base a to logarithm base b? The only thing I know about logarithms is that if I take a and raise to the power log base ax, I will get what? Type in the comments. If I take a to the power of log base ax, I get what? What do I get? A to the power log base a of x is what? Yes, x. This is x. But what is x as well? X is also b log base bx. You see, I'm converting to base b. So here I want to see b to the power something equal to b to the power of something. But here I see a. So what do? I write it as b to the power of log base b of a. And that will give me a to the power of log base ax will be b log base bx, which means b to the power of log base a base b of a multiplied by log base ax is equal to b log base bx, which means what? Which means that log base ba times log base ax is equal to log base bx, which means that log base ax is equal to log base bx divided by log base b of a. Yeah? What it tells me, for instance, is that log base 3 of x is equal to ln of x divided by ln 3. And so the derivative of this function is the derivative of that function, which is simply 1 over x times 1 over ln 3. Are you alive, guys? In much knowledge is much sadness, and he who increases knowledge increases grief. Do you know that? Yes, I think you do, guys. You're becoming wiser. That's why you're sad. Sadness, yes. Sadness is one of the, I think, most intelligent emotions we have, because sadness, guys, I think it means that we either look into the future, far into the future, or we look far into the past, or both. So now you understand, guys, what we just derived. The derivative of log base ax is 1 over x ln a. Notice that for all the logarithms, the derivative involves specifically the natural logarithm. Isn't it interesting? Yes? Very specifically, I involve the natural logarithm. Of course, guys, every logarithm is essentially the same. Did you understand what I just said, guys? Change of basis. Every logarithm is it's a scalar multiple of one another. All right, guys, now let's do a few more merry exercises. I want you to please calculate for me this question, guys. Question A, the derivative of ln of x squared plus sine x, as quickly as you possibly can. Yeah. Yeah. Или просто горе. Грибоедов, горе от ума. It's a good woe from wit or woe from wisdom. It's a play. So yes, so it was said woe from wisdom. You understood, guys? So what's the yeah. So here is the solution, guys. What's the derivative of ln of x squared plus sine x? Have you checked out, guys? Do you need something to entertain yourself with, or are you following me? I mean, I feel like I am basically talking into the air. Is that right? Very simply, honestly. Come on. Guys, simple question. Are you following me? I mean, do you have enough oxygen? Do you have something sweet to eat? I'm not air. Well, good, John. That's good. That's good. I'm lacking oxygen. We'll do just a few, one more question. If you want to, we will take a short break. Maybe you use something, maybe you buy a sneakers. I'm not sure, you know, the commercial or something, right? Something to cause you to think. So the derivative of x squared plus sine x, very simply, derivative of ln is 1 over x squared plus sine x. Derivative of the inside function is 2x plus cosine x. Good? Are you willing to do problem B, or it's too much right now? You cannot do problem B. Too much. Okay, well, at least one person is honest. Where am I losing you guys? Another thing is, do you understand what we're doing, guys? So why are we doing those exercises? You can Google them, right? Now, could anybody tell me, well, I'm always thinking, always struggling to find an example to you. Why bother doing this? You can Google the answers, right? You can make a computer solve this question. Why are you doing it? Tell me really, what do you think? Okay, well, a person is honest, so you're worried about the final. But why are you worried about the final? What is the final going to do to you? So you'll take an exam in a subject that you don't understand, and maybe pass it. And pass it what? What are you passing? Why does it matter? Does anyone here exercise, weight lift, or run, or do any of those things, guys? Do you do push-ups? Does anyone here do push-ups? Right? Oh, Brianna does push-ups. Okay, cool. Or exercise. Now, what are you doing when you exercise? If anybody looked at you, it would be very weird. You do this, right? You are basically executing a meaningless motion. What's the point of that motion? You can also watch it on YouTube, right? Or see somebody else do push-ups. Yes, well, kind of like that. So here you are destroying your brain to rebuild it, hopefully, right? Because you see, not doing exercises, you are weak. Not thinking, you are stupid, right? So you're trying not to be stupid, and that's very, very difficult. I try to not be stupid, and yet very unsuccessfully very often, as I find, right? I was recently trying to figure something out, and then I realized that I was figuring it out in a manner a fly was trying to get out of the window, like, right? Hours and hours and hours, and somebody did it in a second, very, very simply. So yes, that's the thing. How many push-ups can I do? You want to see me do push-ups? You want to count? All right, I'll be doing push-ups. Fine, right? If that's what it takes, I'll be doing push-ups. Are you ready?
I'm saying in a shot, like without like stopping.
Without stopping, okay? I mean, I did push-ups today, but okay, I will try to do as many as I can now, okay? If that's gonna entertain you, fine. What can I do then? Let's see how many push-ups I can do after doing push-ups. And tell me, of course, if it's the right form, okay? I mean, that's the best I can turn the camera for. Can you see me? Yes? Ready? I did before, but that's what I was able to do now. Good?
Now do some diamonds.
Sorry? Say it again.
Do some diamond push-ups.
It's a what?
You should do some diamond push-ups.
What is that?
I think it's when you put your hands together instead of your hands far apart.
Oh, I have a
It's when
bad
your hands
joint
are-
here, so I don't like doing this. Yes, good. So will you solve the question now? Can we use maple on the final? No, of course you cannot use anything on the final. You just have to answer the questions and besides maple will not help you. The questions will be so that it's very difficult to ask a computer to solve them if you don't know what they do. Good? Solve those questions, guys. Solve question A, we solved A. Solve B, solve C, and solve D. We are doing problem number B, guys. Problem number B. All right, so you ready with B, guys? It's here is the solution for B. The derivative is 5 log base 3x plus x, so it would be the same function times ln times the derivative of what we see here. Derivative of log base 3 of x is 1 over x ln 3 plus 1. Everybody says it? Yes? Now do problem number D. Do problem number C, guys, please. See? And try to be fast. All right, fine. So let's do C, guys, together. C is what? It's just well, you don't have to always do that. You can say derivative of log base 3 of 5x. What is it? So here we square the denominator, take the derivative of the numerator, which is 3 over 3x ln 5. Do you see? The 3's cross out. By the way, you can see that it's ln logarithm 5 of 3 plus logarithm 5 of x. So of course it will go out. And then times the function on the denominator minus the roles reversed. Okay, I would like you to do problem number D, please. So it's log base 10 of e to the 5 e to the x. Okay. Let's do this one together. So we want to take the derivative of logarithm base 10 of e to the 5 e to the x. You agree? And what do we get, guys? So before we take derivatives, we can use the properties of logarithms. Look at this, please. Look at this. Do you see that this can be moved in front? Yes, so what is this function? This function is simply 5e to the x times log base 10 of e. Do you see that this is just a number? So the function is very similar to e to the x. The derivative of this expression is simply 5e to the x log base 10 of e. No change, which means that the derivative of this function is the function itself. Yes, the derivative of this function is the function itself. Here is again that thing that we calculate that the derivative of e to the x and e to the y are what they are. Now, guys, we are in this chapter. Maybe one last question. Can you figure out how to take the derivative of this function? And I mean, obviously, you look at it, it looks very ugly, right? So can you do something to make it not ugly? You see this thing, guys? There is a lot of multiplication and a lot of powers involved and all sorts of ugly stuff. So you know what you can do, guys? This topic is in this chapter, we call it logarithmic differentiation. Here is what you can do. Remember those laws, guys. Logarithm of m times n is logarithm of n, logarithm of n. So what you can do is this. This is your y. And instead you would prefer to take the logarithm. Do you see why? If I apply the logarithm, I can break it apart and make it make the division become subtraction, make the exponents become multiplication by the exponents, right? So do you all see how that was obtained, this formula? Let me give you a simpler one and you will break it down, guys. Suppose that you had to take the derivative of this function. You had to take the derivative of f of x, where f of x was equal to x cubed of x cubed times sine x divided by the square root of 1 plus x. Okay? You can do that using quotient rule, do you agree? But there is quotient rule and power rule and all sorts of ugly things. This is x cubed sine x over 1 plus x to the 1/2. But instead, look at it, let's call this y, so that we don't have to write f of x. So instead, what I will do is this. I will take ln of y. Now, what's ln of y? It's ln of this expression. And what's that? This is ln of x cubed sine x minus ln of 1 plus x to the 1/2. Do you agree? Yes, guys? And what's that? This I can break further into what? I can break it into 3 ln x plus ln sine x minus 1/2 ln of 1 plus x. You see what I did, guys? I converted quotient rule. There is, of course, an ln there, but I converted quotient and power rules and all those things. I created this less complicated function. Now the derivative I want is of y prime. So the derivative on this side is what? It's 1 over y. It's 1 over y ln, oh sorry, it's 1 over y times y prime. Are you with me? Taking the derivative of ln is 1 over y times y prime. And what do I get if I take the derivative of the right side? I get 3 over x plus derivative of ln sine x will be sine x on the bottom, cosine on the top. Yes? Minus the derivative of ln of 1 over x is 1 plus x, and then there's this 1/2. This is the derivative. So all I have to do to finish the problem and multiply everything by y, where by this function. You see, guys? So my answer is to multiply this by y. So y prime is y times this thing, where y is this formula. So it's basically, here is my y. Okay, I take x cubed sine of x root of 1 plus x, and I multiply by 3x plus cosine over sine minus 1/2 1 over 1 plus x. And I will have my formula. You understand? Well, guys, I mean, I don't know, understand or not, your expressions are not very joyful. And I mean, what's happening to you tomorrow? Is your skin going to be peeled tomorrow? It's Friday. You're going to have a weekend. Have a good weekend. If you're not staying, if you want, I'll show you something from what, when, where. Some new questions. There was one question I already showed the morning class about Americans and American habits. Well, let me know if you would like to stay, or if not, goodbye, guys. If you have questions for the material or from this chapter, let me know as well. Yes, what, when, where? One about Shakespeare. That was pretty good from the new one. All right, ready? So I'll stop the recording.